Let's get on then with Andy Beaton and the sky this month. Andy.
Hi there. My name's Andy Beaton. I do my observing from the exciting downtown location of Bathurst and Bloor. And I'm here to talk to you about what's coming up in the sky this month. Most of you have heard my talk before, so you know what's coming. The big picture, key dates, the sun, meteors. You see we're going close to far. Aurora, the moon, planets, asteroids, comets. I always like to talk about a double star, and it wouldn't be my talk without variable stars because that's my thing. Something from the deep sky, whatever's coming up in space flight, and emergency planning just in case it gets cloudy. So starting with the big picture, tonight at 10, after astronomical twilight, if we look to the west, this is what we're going to see. Our favorite summer constellations are starting to trickle away. You may notice a complete and utter absence of interesting planets there. We've got the moon, and it's kind of a half moon, so it'd be an interesting one to look at. Lots of nice shadows on the craters and mountains. But if you're looking for your summer deep sky objects, the moon is just going to be a pain in the backside for that. By the time we get to the next meeting, for those of us who like to get up early in the morning and do our observing, now we've got some planets. We've got our favorite winter constellations coming up, Orion and Gemini and Taurus. All our favorite deep sky winter objects. The moon will be out of the way, and we've got lots of planets. We've got Venus just coming over the horizon. Saturn is actually off the screen there, but it'll be nice and high. Jupiter in Gemini is going to be unmistakable. That's one you're not going to miss. So important dates coming up. Since I know this presentation can be seen by people who are not just in this room or even just in this city, I'm mentioning that we have a total lunar eclipse coming up on the 7th. It is unfortunately only visible on the other side of the world. We don't get to see it, but hopefully somebody watching this broadcast gets to have a look and see the eclipse happening. On the 21st, we have a partial solar eclipse. Once again, it's not for us, it's for people in the South Pacific. I believe we've had people comment here from New Zealand and maybe Australia, so hopefully they'll get to see something. Obviously, if we've got an eclipse, we also have a new moon on the 21st, so deep sky observers, that's your key date. Also on the 21st, Saturn is at opposition. That means it's on the opposite side of the Earth from the sun. So it's going to be as close as it gets to us, and it's going to be nice and bright. Fall equinox is coming on September 22nd, and that's the point where our summer is officially over and fall starts. It's also the point where night is longer than day, which is, I guess, good for us, isn't it? As the nights do get longer, twilight is ending at 9:20 tonight and starting again at 4:40 in the morning. By the time we get to October 1st, twilight will end at 8:20 and start at 5:25 in the morning. So we've got a much longer dark night for those of you going to be doing your long-term, long exposure astrophotography. The sun is very active right now. I was just talking to someone in this room saying that we had aurora happening over the past few days. I didn't see any. Mostly what I've seen about it is people on social media saying, I didn't see it either, but keep an eye out for it. It may come along anytime. You never know with aurora. So meteors, it's a lousy time for meteors. We don't get any major meteor showers. The last of the Perseids are gone. We're not getting anything else until well into October, but we do get some minor meteor showers coming up. The September Epsilon Perseids and the October Arietids, though they're minor showers, at their peak, you're getting less than 10 meteors an hour. I wouldn't get out of bed and rush out to the dark skies to have a look for any of these, but if you are out observing and you see a meteor, you can trace back the direction it's flying in the sky and see if it heads towards the star Epsilon Perseus or to the constellation Aries. You may be spotting one of these minor meteors. We also have meteor dribbles, something not even a shower, less than 2 meteors an hour. The September Lynchids and the Chi Cygnids, I don't know why we even bother pointing them out, except that I don't have any good meteor showers to bring you, so bring you some bad ones. This is something I dug up recently while researching my presentations, is that you can do some meteor chemistry. You can tell what the meteors are composed of by the colors that they glow as they burn up. Obviously, this is just for bright ones. The dim ones, they just look white. There's not enough light to set off the color receptors in your eyes. But the bright fireballs, if they're yellow, they are containing iron. Orange yellow is sodium. Violet's calcium, and magnesium is a blue-green color. I've only ever seen orange yellow that I can be consciously aware of. I'm sure I might have seen others that I'm just not remembering. Green and red are different because that's not the meteor chemistry you're looking at. That's the atmosphere. Green is for oxygen in the atmosphere being excited, and red is for nitrogen. We get that a lot with slow meteors. So there's a science project for you if you're ever out meteor watching and see something good. So aurora, as I was saying, the sun's active. We are getting aurora being observed just the past few days. It may be still happening. I was doing some solar observing last week, and there were fantastic, huge prominences. So the sun is in an active time. So we never know what's going to be happening. The northern horizon, looking for a pale glow, that's probably what you're going to spot first. My experience is it just looks like city glow, but if you take a picture with any modern smartphone and you find that the glow is actually glowing green, then you've got aurora, because that's not the natural color of city light. The place you can check to see what's happening with the sky is spaceweather.com. That's where I go to see when I should be expecting aurora and to hear what other people are observing. So we've got the moon, full moon on the 7th, new moon on the 21st. I'd like to point out September 10th and September 26th, we have perigee and apogee. That's when, nuts. There's my first typo of the presentation. Perigee is close, apogee is far. What we want to do is take images of the moon at those two different dates and compare the size of the images. You can see that when the moon is farther away, it's noticeably smaller. And there's evidence that you can gather yourself that the moon is in an elliptical orbit. I like these little science projects that you can do yourself. The lunar X is visible on September 29th. What the lunar X is two craters side by side. And when the sun is illuminating the crater rims at just the right angle, it looks like a lit up X against the black shadow on the moon. Scientifically, it means nothing, but it's neat. And it looks fun, and it's an interesting way to drag yourself out on a cold night to go and look at the moon, which is always worth looking at. Straight wall is another lunar feature that's worth looking at. It's on the evening of September 30th. It's a long, straight rill on the moon's surface. When the angle's right, it shows up as a brilliant shadow. And it looks neat because you don't really see straight lines in nature very often. This is one of them. Now, the really interesting thing coming up on September 8th or 9th, I don't know who knows their orbital mechanics terribly well, but the moon wobbles back and forth as it orbits the Earth. A process called libration is going wobbling back and forth. When it wobbles this way, we can see a feature on the far side of the moon, Mare Orientale. It's a lunar sea, which is just on the around the corner. When it wobbles the right way and the sun is illuminating the moon from the right angle, you can actually see this far side of the moon feature. It was only identified a few decades ago, so you're seeing stuff that astronomers missed for centuries. So yeah, put that one on your observing project list. So planets, starting with the rocky planets, Mercury is hopeless, forget it. On the other hand, Venus is bright and visible in the morning sky. If you're going to look for it as soon as possible, because as the month progresses, it's sinking lower and lower into the morning sky as it's getting ready to pass around the back end of the sun. Mars is visible in the evening, sort of. It sets before twilight is over, but it's really too far away to see any interesting detail on it. The sky is going to be too bright. So unless you have a weird obsession about seeing Mars under any and all circumstances, that's one I wouldn't bother with. Now, the gas giants are the planets that everybody loves. Jupiter is the bright one this time, but you need to wait until 2:45 in the morning for it to rise. And it's a -2.5 magnitude. It's insanely bright. You're not going to miss it. It will be so obvious that everybody's going to point and say, yeah, there it is. This month, there are multiple double shadow transits. What this means is moons of Jupiter orbiting around it are causing eclipses onto the surface of Jupiter and casting shadows. And every now and then, you can see the shadow as it transits across the surface of Jupiter, and it looks neat. It doesn't take much of a telescope to say, okay, here's a black spot that you can see. That's a shadow crossing the surface, but every now and then you get two of them at once. And the geometry at this time is such that we're getting a bunch of them happening over the next few months, several in this month. The RASC handbook is your best place to find these listings, or your planetarium software. Set it up to look at Jupiter and hit play and let it run until you see the interesting shadows that you want to look for. I'm guessing everybody with a telescope has seen the 4 big moons of Jupiter. If you have a bigger telescope, and I know some of the people who are going to be listening to this will, try for some of the smaller moons, like the Amalfi and Himalaya, down in the 12th and 13th magnitude range. I know that there are a lot of advanced observers in our club here, and I want to make sure they have something to look forward to as well. So Saturn is up all night. That's going to be the showpiece for all the star parties for the next few months. It's bright, not as bright as Jupiter, but still pretty noticeable. Unfortunately, the rings are very close to edge on. It doesn't look as cool as it does as when the rings are wide open. Um, on the upside, when the rings are close to edge on, you can find the moons a lot easier because you're getting a lot less glare outside the disk of the planet. I was doing some observing a couple of weeks and got a couple of moons down in the 12th and 13th magnitude range, something that I could not do when the rings are at full brightness. Titan is an obvious moon, but there are 7 moons brighter than 13th magnitude, according to the Observer's Handbook. So some of those should be reachable with most telescopes. Then we get to the boring planets, the ice giants, Uranus and Neptune. They're not boring, they're interesting, but they're not really exciting to look at. Uranus is brighter than 6 magnitude, easy to find with binoculars, not very big, 4 arc seconds or less. But some large telescopes, you may be able to get some of its moons as well. And I'm going to draw your attention to a scientific question that has bugged me a long time, which is whether or not it is blue or is it green, and how does it compare to Neptune? Last time I was looking, I thought Uranus was blue and Neptune was greener, but other times I'm never really sure. Anyway, take a look yourself and see what you think. Neptune is also up all night, rises around 9:30, and it's pretty close to Saturn. So if you have a wide-angle camera, you might get an interesting image with both planets. It's not very big, but Moon Triton is findable. I think it's something in the range of 13th and a half magnitude. Could be done with an 8-inch telescope under good conditions, but you'd want something bigger than that if you want to be certain. So the dwarf planets, we've got 2 of them that we can see. I mean, there's a bunch that we could maybe image with a giant telescope, but I don't think that's me, and it's probably not you. But Pluto is achievable. It's in Capricornus, just over the border from Sagittarius, 14 and a half magnitude. I saw it 15 years ago when it was brighter than 14th, and it was a hard slog on an 8-inch telescope. I'd say you probably want something 12 inches or better if you're going to try for it this time. It's tough visually because there are so many dim stars around there. It's really difficult to get a certain identification. Best method is imaging. Get a bunch of images and compare them night to night, week to week, and look for that one that moves. Same way it was actually discovered. Ceres is the other minor planet that's the dwarf planet that's visible. It's in Cetus, 7th magnitude. It will be an interesting project because it'll move quickly. It moves about 5 arc minutes from night to night. So mapping it from night to night, week to week would be an interesting project. When I was in university, we were actually given the project of measuring and calculating the orbit for it. That's a lot of math. Some of you might want to do it. I imagine most won't, but you can at least consider it a possibility. Or make your kids do it. That'll be a good math project for them. Since Ceres is no longer an asteroid, I'll draw your attention to other asteroids. There are a few asteroids visible brighter than 9th magnitude tonight. Pallas, Julia, and Hebe. There are dozens and hundreds and thousands more as we get to dimmer and dimmer magnitudes. Whenever I go out observing, I always like to see something I have never seen before. And if you're observing in the city, galaxies and nebula are right out. but finding an asteroid that I'd never seen before is actually a pretty manageable task. You know, dig through your planetarium software, check out the area of the sky you're going to, find a likely looking asteroid, mark it on a map, and go looking for it. It can be done. Comets, it's a lousy month for comets too, or at least it was when I was checking earlier on. C2025 K1 Atlas at 12th magnitude. It's not an interesting comet. Even with a large telescope, a small fuzzy blob is the best you're going to get. There's going to be no spectacular tail or anything that is going to impress people. If you've never seen a comet, yeah, I guess look for it. It would be exciting. But actually, no, if you've never seen a comet, wait till a better one comes along. You'll just be disappointed. If you're a real comet lover, though, there's a few 15th magnitude comets, 217P linear, C2021 G2 Atlas, and 240P neat. That's probably as good as you're going to get. Hopefully, we'll get some better comets coming up. My late friend Blake Nancaro got me hooked on observing double stars, and this one is an interesting one, I guess. I'll tell you why. It's a fairly bright pair, fairly wide, far apart. Just about any telescope is going to be able to split them. The Observer's Handbook rates a bunch of them by their aesthetic value. It gets a 1 exclamation mark out of a maximum of 3 for beauty. So it's nice. It looks pretty. Now, here's the thing. The Observer's Handbook describes the pair as yellow and red. So when I was researching this, I went and looked, and they looked white and blue to me. So here's another science experiment for you. Go out and look at Capua Herculis, and do me a favor, note the colors that you think you're seeing, and send me an email, because I'm curious to see what other people are observing here. I mean, I don't want to say the Observer's Handbook is wrong, but I don't want to say that I'm wrong either. So it's an open question there. I'm curious to see who you think is wrong. So here we are. Here, there's a little map of it. Corona Borealis and Hercules there. And down near the bottom corner of Hercules is where Capua Herculis is. So not too hard to find, fairly bright. So there's yet another observing project for you. Now, because it's me doing the presentation, you're getting a variable star, whether you like it or not. Z Andromedae is the one I picked this time. It is what is known as a symbiotic variable star. It's a class of cataclysmic variables. Goes from 7.7 to 11.3 magnitude. And what we have is a white dwarf and a red giant orbiting around each other. The extended atmosphere of the red giant is very tenuous, and the more intense gravity of the white dwarf is slurping up material from the atmosphere of the red giant. And as it accumulates on the surface of the red dwarf, when enough accumulates, it will ignite a brand new burst of fusion. Now, these ones are interesting because they are fast and not entirely predictable, which means they are not going to be easily caught by all the automated sky surveys. The Vera Rubin telescope does a complete sky every 3 days. A variable star like a Z Andromedae type will ignite over a course of a few hours. Now, astronomers who are interested in these things don't have time to sit in front of a telescope for weeks or years on end. Here, let me just jump ahead for a second. Here is the light curve for Z Andromedae. This is over 10 years. So if we take a look, 8 years ago, there was an outburst up to 9th magnitude. And it went up fast there. Now, if I were a professional astronomer observing variable star, I'm not going to sit in front of a telescope checking Z Andromedae every hour for 10 years. This is the kind of stuff that can be handled by astronomers, amateur astronomers like us. You know, there's lots of us. Many of us are looking for a real scientific project to work on. We can go out, it takes us 20 minutes to make a measurement here. We can probably do 10 or 20 stars in a night. And that data is waiting there for professional astronomers when they need to do their calculations, do their studies with all that data. So this is a way for another way for us amateurs to actually contribute to real science. Now, the other variable star, T Corona Borealis. What the heck is going on? I stood up here a year ago and I said, this star is going to ignite. It's going to be spectacular. And a year later, nobody knows why it hasn't gone up. Normally, 10th magnitude goes up to 2nd magnitude. Here here's a little map of Corona Borealis with T Corona Borealis down in the corner. It's going to be super obvious. It's an easy constellation to spot, and it's going to be the brightest star in the constellation. So it will be easy to see. The only question is, why aren't we seeing it? At this point, I think the question of why we aren't seeing it is almost more interesting than why we would be seeing it if it did go off. So anyway, astronomers around the world eagerly awaiting this outburst. Maybe you could be the first to spot it. So I always like to point out a few things in the deep sky that people can add to their observing project list. I've gone for M8, the Lagoon Nebula, and there it is, according to the ESO Paranal Observatory. It's not going to look like that to you and I, but it's a rough thing. But I want to point out a few things. One is the black stripe going right through the middle, and the other is the little black blobs throughout it. So it's a nice bright nebula. It's so bright and contains bright stars, makes an excellent target for beginning astrophotographers. And the reason I say that is when I was trying out astrophotography, getting a good focus on a nebula was very difficult to me because it looks like a gray blob even when it's in focus. This one has nice bright stars, so that'll be nice and easy. If you're an experienced imager, gas tendrils connect it to the Trifid Nebula. That's going to be really deep sky stuff. You're not going to get that from downtown Toronto. But if you're viewing it through an O3 filter or some other similar sky filter, then you can cut down the glare from the stars, you can blacken the sky and see a lot more detail than you would expect for just the naked eye. Area known as the hourglass in the brightest part of the nebula is worth seeing. And those little black blobs I was pointing out are Bok globules. And what those are stars that are forming that have not yet brightened to the point where they're shining. They're just black blobs of contracting gas and dust. I've never seen one through the telescope. If I had a much larger telescope or a photographer, then maybe I could do it. And for astronomers who are just in their early stages, it's part of the Messier certificate. What we have here is 110 objects recorded by Charles Messier back in the 18th century, reminding himself which blobs in the sky were not comets. But among those, a lot of interesting things: star clusters, nebula, galaxies, all things that everybody should see at least once. Seeing the entire Messier catalog, it's a good grounding for what you're going to be able to find in the night sky. And you can get a certificate for it and put it on your wall and show it off to your friends and family. So if you're looking for M8, there we go. There's the teapot in Sagittarius. And there's M8 bubbling up in the cloud of steam that's the Milky Way. Now that's very nice for the astronomers just getting started here. If you're looking for something more challenging, the Veil Nebula is one I was looking at a few days ago. It says the brightest supernova remnant in the summer sky, and that's, I guess you would have to argue that the Crab Nebula is in the autumn sky because that should have been the second brightest. It's about 20,000 years old, so it's really spread out and really, really dim. But if you can see it with a largest telescope, maybe an O3 filter to help, it is quite spectacular. You see all kinds of lacy structure and tendrils and bands all wound together. It's quite beautiful. And I was reading that the Hubble Space Telescope has measured changes in the Veil Nebula over a space of 18 years. And I know there are people who are very serious about astrophotography who are getting remarkable images. And I'm wondering how long it would take an amateur with an amateur scope to be able to detect any kind of change. I would say younger astronomers get at it now, and hopefully when you're an old astronomer, you'll be able to detect that change. Now, for really serious people who are looking for something they've never seen before, this is beyond the Milky Way. It's a Mayall 2, and what it is a globular cluster orbiting the Andromeda Galaxy. It's just brighter than 14th magnitude. It's 130,000 light years from the center of M31. See, there it is. There's M31, and there's Mayall 2 down in the corner of the image. So it's a good distance away. You'll want a really good star map or planetarium software to find it. But it's the brightest of 500 globular clusters that have been identified around M31. I have seen it in an 8-inch telescope under superb conditions. And the good news is it really looks like a stellar object from here. It's so far away and small. And stellar objects or things like it are the best things for getting through light pollution. So it's probably going to be very difficult from the city, but outside the city, even with a certain amount of Toronto sky glow, it should be reachable. And that's got to be a cool thing, seeing a globular cluster around another galaxy. So spaceflight, we've got a few things happening. Cygnus spacecraft is going up to resupply the ISS on September 15th. The Interstellar Mapping and Acceleration Probe, or IMAP, is launching on September 23rd. Escape and Plasma Acceleration Dynamics Explorer, September 29th. Now, I was watching on the weekend for a company called Nord Space to launch a rocket from a Canadian launch facility in Newfoundland. It was canceled on the day I was watching it. I don't know if they have launched yet. Have they launched yet?
They have not launched yet, but the CEO told me that it was sometime in September. They just need approval to get through the government.
Okay, for those who are not able to hear that out on the internet, apparently they are waiting for government approval for their next upcoming launch attempt sometime in September. And we also have the ISS. It'll be passing over early in the morning until September 7th. And after that, there'll be evening passes until the next meeting. I can't give exact times because it varies so heavily with where you are. So go to heavensabove.com for exact times for your own personal location. Now, if you'd been to the CNE and you lost your glasses on the Crazy Mouse and you're looking for astronomical projects, Galaxy Zoo, zooniverse.org, has dozens of astronomy-related citizen science projects. A few of them that I picked out for this month. Rubin comet catchers, that's data from the Vera Rubin Observatory looking for comets. Cosmic collisions between galaxies, Einstein at home pulsar seekers, and active asteroids. Are they asteroids or are they comets? That's up to you to decide. So we know it's going to be cloudy sometime. There we go. We've got some astronomical projects that we can work on. So if you have any questions, feel free to email me, andybeaton@gmail.com. I'm on Blue Sky or on the RASC Toronto Centre Forum. Thank you very much.
Thank you very much, Andy. Any questions from the audience? No questions? Oh, wait, question from Frank.
Not a question, but a comment. So it's worthwhile to point out because some people will find it interesting. This is a year for some rare instance of passage of Titan's shadow across Saturn's disk every 2 weeks, every 16 days actually, a few times this year. So one is coming up tomorrow morning, basically about 6 hours from now. It's irrelevant for Toronto area because it'll be raining or pretty darn cloudy. But it might be some people online who might be interested to know that that's a rare sight to see, and there's been a few already this year, and there'll be maybe 2 more until October. So one of them is tomorrow morning. So just wanted to mention that.
I have never seen a transit of Titan shadow across Saturn, so thanks very much, Frank. I appreciate that.
Yeah. So just so anybody knows, I need a very clear view of Saturn, and Titan is a tiny dot, of course, and the black dot of its shadow is visible under good atmospheric conditions, not hazy or cloudy like tomorrow morning, but very clear sky. And I've seen a couple, and they're pretty distinct and pretty rare to see. So in case anybody online has a chance to see it tomorrow morning, it's worthwhile to mention. Very rare event tomorrow morning.
Cool.
Okay.
Thank you.